question, and you have practiced a lot. For k, you have a function within a function, which again requires you to use the chain rule. So the derivative of the outside h prime with the inside the same, f times the derivative of the inside, f prime. Do you have k prime at x done pretty well so far? Okay, that was 1 point, the chain rule. Now, k prime at pi is going to take a little bit more work. H prime of f of pi times f prime at pi. I went off to the side and found f prime. Here's f, or not f prime, f at pi. What is f at pi? 2. So that means h prime at 2. F prime at pi. If you evaluated that incorrectly in part A, but then you use that value in part B, they would give you carry through errors, so they wouldn't count you off again on that. So as long as you used your result from part A there, you would still be in on full credit for part B. H prime at 2, though, involves looking for the slope at 2. What is the slope at 2? Negative down 1 over 3, so it looks like negative 1/3 times negative 1. Did you get a positive 1/3? Okay, that was 2 points. 1 for the derivative, 1 for the correct answer, putting pi in. So that's 2 points. So far I'm working on a 9 still. I hope you are as well. Part C, you've got a product and a chain. So in this case, to find m prime, you're going to have to use the product rule with a little chain rule thrown in. So I said first stays the same, g of negative 2x times the derivative of the second, which is h prime, plus, not minus, that's quotient rule, plus second stays the same, h times the derivative of the first. What's the derivative of g of negative 2x? Negative 2 g prime of negative 2x, right? That is the first point. Did you find m prime of x? The second point then is, did you deal with this at 2 correctly? That means g at negative 4, which is from the table, h prime at 2, which we already know, I think. H at 2, which you had to do a little thinking of that on the graph. And g prime at negative 4. We? All said then. What was g at negative 4 according to the table? What? 5, yes. What was h prime, or h's slope, at 2? Still negative 1/3. What is h at 2? Negative 2/3 times a negative 2. And what's g prime at negative 4? It was negative 1, wasn't it? So overall, did you get a big fat negative 3? Yes? This was actually, sorry, I take it back, I had the points wrong. It was 2 points here for m prime, product rule with chain rule, and 1 point here for the correct answer, negative 3. So that is out of 3 there. Okay? Are we still in for a 9? Ah, baby, all right, here we go. Let's see if you fumbled at the 1 yard line. If they say g prime is equal to negative 4, there are 2 possible approaches to that. You could look at the g prime column and say, oh yeah, negative 4 is in there. And if negative 4 was somewhere in there or somewhere in between, you could use IVT on g prime, right? But is negative 4 enclosed anywhere in g prime's column? No. So does that mean no, g prime is a no negative 4? No. You should also investigate MVT. Now they actually are throwing you a bone. They're telling you where to look. They're saying, is there someplace in negative 3 to negative 5 in the question? So you go there. And if you look at the average rate of change there, it is down 8 over 2. That is negative 4. And the answer is yes, there is a place. So you should say something like, meet the conditions for MBT. What are the conditions? It's continuous and differentiable. G is differentiable, and I just said parenthetically, so also continuous. So the MVT guarantees, or something along those lines, a point in -5 to -3, where G prime at that point is equal to, now here's where you actually show the difference quotient, the MVT. G of -3 minus G of -5 over -3 minus -5. That is 10 minus 2, or is it 2 minus 10 rather? 2 minus 10 over positive 2, and that is indeed -4. The average change on that interval is -4, so there's got to be a place where the instantaneous change is -4 also. That was 2 points. The scale, or the points on that were, if you had this in your work, that was 1 point. The other was saying the conditions are met, it's differentiable and continuous, MVT, and then basically saying yes, there is a place. Okay, so that's 2 points. Are we talking 9 people? Are we talking 7?
Yep.
You should have a 7 at least. I feel like the last one, okay, you gotta be on your game, but you should probably be able to do that 7 minutes. Yeah.
Or like right here instead of like I didn't put G but I just wrote it. And then I wrote it again down there. Like
I think you can. I would have to pretty good. All right. Okay, so real quick, let's talk derivatives. If you flip it over to the front, and let's talk some notes. Here we go. How did last night's review go? Did you do it? All right. Okay. So, big ideas that are not meant to teach, but to jog your memory in a couple months if you look back at these and say, oh yeah, I remember that. Okay? So, average rate of change, or secant slope. If you talk, would you maybe make 3 different cases? Say you looked at the change between this point was just x, and then you maybe went a gap of h away to x plus h. Then the slope between those would be the change in y. Slope is always change in y after change in x. Change in y is f at x plus h minus f at x over change in x, which is x plus h minus f. That's the slope between 2 points. And that's just any old points on the curve. You could look at this slightly different, and you could say, all right, let a be a certain number on the curve, a constant, and x is any other point on the curve. In that case, then, the slope would be the difference in the y values, so the difference in f at each point over the change in x, or the difference in the x's. That's the slope, delta y over delta x. That represents the slope between those 2 points, yay? Or, possibly, you could let x be some point in the middle and go h on either side. Now, if you went h below x, that would put you at x minus h. If you went h above x, that would put you at x plus h. If you then drew the slope between those, and the rise is f of x plus h minus f of x minus h over x plus h minus x minus h, the difference in the x's. Are you with me?
yes.
Cool. Now that is all average change. Change between 2 points. If you talk instantaneous rate of change, then you need to get the points close together, which we do by using a limit. that makes the derivative, okay? Yes. Sometimes, in fact, you will hear the derivative referred to as the limit of the difference quotient. You got to be a major math nerd to refer to a derivative of that nature. Okay? Now, that said then, in this first case, if you take this guy, h represents the gap. So to get the points close together, you take the gap down to 0, which means h goes to 0. The limit as h goes to 0 of f of x plus h minus f of x over, I'm going to clean up the bottom. What is x plus h minus x clean up to be? H. That's, h is the change in x, so that's the gap. Okay, that's the first definition of the derivative. Newton and Leibniz's original idea. Another possibility is this guy. Now this is meant, this by the way, that would be the derivative at any point x. It's a rule for calculating the derivative at any x. This guy is actually going to calculate the slope at a. If I take x closer and closer and closer and closer to a, then it becomes almost the slope at a. I do that by taking x towards a of the difference quotient. That is the ultimate definition of the derivative. And the last is, if you approach from a symmetric way, if you took the h down to 0 on both sides, then you're going to approach the change at that point, and that is again a derivative rule for any x, and it's done once again by taking the gap, which is h, down to 0. The top can stay the same, f of x plus h minus f of x minus h, but let's clean up the bottom. What is x plus h minus x minus h? 2h. The gap is 2h. That makes sense. It's h on the other side. Are you with me? All right. Now it is guaranteed. There is a, besides the sun rising in the east, there's also guaranteed to be one, at least one, definition of the derivative recognizing a problem on the test. So for example, if you see this kind of thing, the limit as x goes to 2 of natural log of x minus natural log of 2 over x minus 2. Now, on direct substitution, that appears, if you treat it like a limit problem, it feels like 0 over 0, right? I guess you could use L'Hopital, but if you see 0 over 0, you should suspect, oh, maybe this is L'Hopital, but maybe it's a definition of the derivative. Is this a definition of the derivative?
Yes.
Which definition? At a point or at any x?
At a point.
It is at a point. So you would then take it in that direction, the derivative of log at 2. Therefore, your answer is 1 over x at 2, which is 1/2. And you're welcome. You follow me? Estimating a derivative from a table. Sometimes you can't actually get the derivative at whatever, 2. Maybe all you have is 2 points close by, like 1 and 3. Now I could take the change between 1 and 3, and that would be a pretty good stand-in for their slope at 2. So you would say something like change in y over change in x over an interval approximates f prime at 2. Be careful. If a free response question says estimate, then underline it and make sure you use that, because they will be looking to take off if you say the derivative at 2 is exactly equal to the change between points nearby. It's not equal to, it's an approximation. You with me? Great. A derivative doesn't exist if, give me 3 reasons a derivative doesn't exist. Cusp, I'll just call it sharp turn. It could be a corner or cusp. What else? Whole, discontinuity. Or vertical tangent. All of them have their problems. This is the worst case scenario. In most cases, it's a multiple choice question. They say, at which point doesn't derivative exist? And it's easy. But a worst case is every 5 years or so, you'll have to prove. If in a free response question, they say prove f prime does not exist, then you have to do the alternate definition and show one-sided limits not equal. That's pretty gross. Okay? Most of the problems are not that bad. Okay? They're layers. So the problem is if it's, so say it looks like this, the slope, it's continuous, so that doesn't rule it out, but the slope from this side approaches, if you look at this as x and this is a, the slope from this side approaches -1, but the slope from this side approaches +1, the limits are different. Okay? That's why sharp turn is enough. Interpreting a derivative as a rate of change. This was on the test last week, and it was, okay. So, if you're going to listen to one thing for the next 2 weeks, listen to this, okay? When you see rate of change, think derivative. If it says amount of change, think integral. Okay, that is as fundamental as you can get. Okay, rate of change, derivative. Rate of change, derivative. Rate of change, derivative. If it ever asks you to interpret a derivative, the word rate better be in there. All right, now, if, for example, in a free response question, this is pretty common that you have to do this. The height of a tree as a function of time is given by that deal, where time is in years and h is in feet. H prime at 3 is 3.710. Interpret this result in the context of the problem. All right. So I would personally start by thinking h prime of 3, instead use Leibniz notation, because then it's clearly a rate of change. It reminds you, oh, I'm comparing changes in height, differences in height to differences in time. It's a rate of change. So you would say, at time equal 3 years, the height of the tree is, you must interpret the sign when you interpret a derivative. So it's not changing at a rate of, it's increasing or growing, increasing at a rate of. If they don't see rate, they're looking for that word. If they don't see rate in there, you're probably going to have a hard time getting credit. At a rate of 3.710, and now the units, what? Feet per year, because it's height per time, feet per year. You follow me?
Yes.
I made this problem up, and that's really growing fast. That's crazy. I don't think trees grow 3 feet in diameter a year, but whatever. Okay. Never know. Notation. This is, again, not meant to instruct, but to warn you about common lost points on the AP test. All right? So, for example, if they say f of x is cosine of x, what is f prime at pi over 6 in a free response question? Obviously, if it's multiple choice, they don't look at your work. But if you blend general into specific, they will count off. So, for example, if you say f prime at pi over 6, well, f prime at pi over 6 is negative sine of x, which is negative sine of pi over 6, which is negative 1/2. You will not get credit for that. What's wrong with that? Okay. This here is the general. That's the derivative at all points. This is the specific. And to merge one into the other will cost you points. And so there's 2 proper ways to do this. That's a no, for example. One is to say f prime at pi over 6, it's negative sine of x, and I'm going to evaluate that at pi over 6. I'm showing you the general derivative, and I'm about to put pi over 6 in, and then rock and roll, and you're good to go. You with me? That's fine. That's good calculus. Also, you could say, or just separate the 2 into 2 steps. The general derivative is negative sine x. And the derivative at pi over 6 then is negative sine of pi over 6. And go from there. All right? But please don't blend general into the specific. Make sure you separate those two items. Derivative of a constant. This happens most frequently on an implicit. I can't tell you how many times if I say dy dx that I would see 2x plus 2y dy dx equals 10. And that's not true. I took the derivative of both sides. The derivative of that is 0. That is usually a careless mistake. I think you know that a constant doesn't have a rate of change. It doesn't change at all. That's why they call it a constant. And so just be careful there. The power rule is the greatest shortcut in all of mathematics. If the function is x to the n, then the derivative is nx to the n minus 1. Please be careful not to use that in the wrong way. For example, if I say f of x is sine of x to the x, I guarantee you there will be a multiple choice on there where they say, is this person thinking they can use the power rule here, and this is x times sine of x to the x minus 1, and is that true? No. That is garbage. That is bad math. How should you approach this? If you have a variable in the exponent, you use logs to bring down the x. Okay? Use logs. All right, so be careful not to use the power rule when it's not appropriate to do so. Always simplify first. You will make your life a nightmare, especially on the second derivative, if you fail to simplify as you go. Let me give you an example. Let me say this. What if you had 5x to the 6th plus x to the 4th over x to the 4th, and you wanted the derivative? Could I bust out a big old quotient? I surely could, but that would be a disaster. Instead, I would, or person on their game would say, first of all, I can divide out an x to the 4th. I have a whole at x equals 0, and so there is no derivative at 0. But otherwise, it is 5x squared plus 1. And the derivative then is, instead of all that quotient rule, it's just an x. Done. Okay? Make your life simple, especially in the second derivative cases. If you take a derivative, for example, by product rule here, and then they ask you for the second derivative, it's so much easier if before you do more derivatives, if you say, can I make my life easier first? For example, here you might rewrite this way and make your second derivative a little cleaner. All right? Product rule is if you take the derivative of a product, f times g, it is what? First case the same. Derivative of the second, plus or minus? Plus. Derivative of the second, or sorry, second times the derivative of the first. I guarantee you there will be a problem like this on the multiple choice, and I guarantee you that one of the choices will be there to get the knucklehead who doesn't know how to use the product rule. So if, for example, I got this problem, I guarantee you one of the choices would be 1 cosine of x. That obviously is a person that knows zero about the product rule. They're in way too much of a hurry, and they just lost an easy point. Okay, so I think we know that you don't just take the derivative of each part, right? Right. Quotient rule, same deal. If you take the derivative of f over g, it's low. It's got a rhyme. Low g d high f prime minus
pi
f below g prime over the square of what's below x squared. Oh, one more thing. Would you go back to notation? And I meant to talk about this. Some of you have this terrible problem of, if I'm doing a derivative, if it's got f in it, great, I'll use f for my derivative. If it's got g in it, don't care, I'm still using f in my word. If it's got h in it, I don't care, I'm still using it. You will lose points if the problem says h of x is this, and you say my derivative is f prime. You just got 0. It doesn't matter what you write after that, because there's no f here. I can't tell. I've written about 100,000 times this year. There's no f. There's no f in this problem. Okay? Why do you use f every time? If there's no f, don't use f. Jeez. F this, f that. I am not. Chain rule. Chain rule is when you have a function within a function. And what must you do? Talk to me. Derivative of the outside f prime with the inside the same times the derivative of the inside. Okay? Some of those times it's the most obvious. For example, if I say, hey, 1 over e to the x, that's a gotcha problem. You feel like, oh, it's e, so it's good. 1 over, no. You think, oh, there's no chain rule there. Is there a chain rule there? Yeah, because you're going to take a second to rewrite it. And you say, oh, yeah, there's a chain rule there. It's negative e to the negative x, right? Implicit differentiation, be able to use first or second derivative. But most importantly, pay attention to words like derivative with respect to. Is it with respect to x? Is it with respect to time? It matters if you're differentiating with respect to x or time, especially in related rates. All right? Boom, study and memorize. Some of these you need to know down cold. I think you know the derivative of e, sine, and cosine, and log. Right? Those you have been doing a million times and you know all those, yes?
Yes.
Okay. Do you know the derivative of tangent?
Secant squared.
Secant squared. Do you know the derivative of cotangent? Negative cosecant squared. Do you know the derivative of secant? Secant tangent. Do you know the derivative of cosecant? Negative cosecant cotangent, yeah? Do you know the derivative of arc sine? 1 over root 1 minus x squared. The derivative of arc tangent is also expected to be memorized. 1 over 1 plus x squared. Okay? Let's go to, do you recall the derivative of an inverse? 1 over f prime at f inverse. Okay, and you have to be careful on f inverse. Do you recall the derivative, of exponential, a to the x? Now, if you get stuck, if you don't remember, you could always use logarithm. Remember when you have x in the exponent, you can always use logarithms to get unstuck. You could say, well, the log would be this. If I took the derivative, it's that. And so dy dx is log of a times y, or log of a times a to the x. Log of a to the x. The antiderivative is a to the x over a, which we'll talk about in 2 days. Do you remember the derivative of log base a? It is 1 over x natural log of a. Again, if you get stuck, you could do it conceptually. You could say, well, don't know the derivative, but I could say a to the y equals x. I could take the log of both sides, and you could get unstuck that way. That's where it comes from. Dy dx, or y is log of x over log of a, so dy dx is 1 over x. Okay. I forget. I got interrupted when I was making my notes. I can't remember the else. Okay, tangent lines.
Wait, do we have to know?
Which one?
Oh, wait.
Am I forget? If you can think of what I'm forgetting, please let me. Okay. Oh, for absolute value, what do you do? Piecewise. You use piecewise. Then take the derivative of the pieces. Feels like I'm forgetting one. I can't remember. All right. Remember to take log if there's an x in the exponent. Okay. Tangent and normal lines. Tangent, slope is obviously the derivative. Make sure that you write it. Don't just say the slope is 5. You need to, on a free response, to communicate. The slope is f prime, which is 5. They are looking for you to communicate the calculus. You make sure you show that. Normal line is just the reciprocal or the opposite reciprocal slope. It's perpendicular, so it's opposite reciprocal slope of the tangent. Make sure point, slope. I still have people that just steadfastly refuse to bind the point slope. They do slope intercept and they make a mistake. That to me is foolish. Slope intercept is just as good, more useful, and less likely to lead to a mistake. All right. That's it. Questions on the review? I think I posted the key online, but if you'd like to talk more about it, let me know. The gold one. The gold one is due on Friday, but if you want to turn it in early, I'll get it back to you tomorrow. So if you can turn it in earlier, but it's due no later than Friday. What?
Can you explain?
7? 7E, yes. I think one of those I forgot to number. I apologize. There's one in it was squeezed in there. No, it's constant. Yeah, like 3. Yeah. Okay.
Oh,
Did you say 7?
yeah. 7.
7E and
11.
12.
11, yeah.
11 and 12. All right. Here we go. 7E. Yeah, I'm not sure what I was getting at, if I made a mistake there, but 7E, I could think, so first of all, do you agree that in terms of acceleration's relationship to velocity, I would be looking for some place where is the average change in velocity equal to 50, so I could use MVT. And try as I might, I found absolutely no cases where the change would be 50. Right? Am I wrong? So that I can only assume it was a defective problem where I screwed something up because I saw no evidence to support that. So not necessarily. That could have been a good MVT case, but I'll get it in there. So don't worry I'll get you some facts. Okay. 11 is 11. It's on page 3. Yeah, this one's a tough question. First of all, just in terms of test strategy, it always feels wrong if all of them are false. Surely one of them's got to be true. But it is what it is. So F has a horizontal asymptote at y equals 0. Let's talk about whether that must be true. And when you get into horizontal asymptotes happen as x goes to infinity or negative infinity. They don't happen inside. It's as x goes to infinity. So to answer this question, I said, all right, well, what happens as x goes to positive or negative infinity? And then check it out. Now, wouldn't you agree that because there's more power in the numerator, it goes to, the inside goes to infinity, yes? Okay, so it's tempting to say then that cosine goes to infinity, but remember, cosine looks like this. And so, okay, if it goes to infinity, that's great, but cosine of numbers out here just bounces back and forth between -1 and 1. And so it never really approaches a single value. So I said, no, there's no horizontal asymptote. Cosine of bigger and bigger numbers continues to just go back and forth. So that's enough. You with me? Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Okay.
Okay, time is running out. Get your SLAM registration forms to get them turned in before it's too late. Don't miss out on a great time.
Students, remember, you can only check out courses for the 10th hour. There's a 10-minute time before that.
Okay. Vertical asymptotes, they happen
Hey Dad, this Friday is the last day to
because
purchase your
there's
online for
a
$75.
zero in the denominator. Now, I would imagine a lot of people said true here because they probably said, yeah, x equals 0, that's true. And that is actually not true because it's still the cosine of. All right? And as this...
Seniors, the countdown is on. 6 days until National College Decision Day on May 1st. This date represents the deadline for students to submit their
So I'm
acceptance
thinking, well, maybe as x goes to 0, it's a vertical tangent because it's a 0 in the denominator. You with me? That's very logical. Here's the problem, though. At vertical tangents, the curves go infinite, yeah? Now, inside be darned, this, yes, I agree that this, as x goes to 0, this gets small, but it's still small in the denominator makes huge, and so it's still the same idea. It's still cosine of infinite. Cosine of infinite does not get big. It's still cosine, and it's still between -1 and 1. So it's still a no, not vertical asymptote. And 3.
Senior high student council meets today, Mr. Bean's room. Sign up with your social
X-intercept of 1.
needs everyone there.
That just means when x equals 1, y equals 0, and that is a... Well, is the cosine of 0 1? Or 0? Oh no, the cosine of 0 is 1, not 0, so no, that's not a... None of them are true. All of them false. Hi!
Attention 7th and 8th
Whoa!
Don't step on the line. If you have not yet received your registration form in the mail, you can still make one out from your seat.
12! Is 12 still a question? Okay. This is a fill the hole problem.
Is that for you or
No, you don't need the derivative here. Okay, so the idea is this. Do you agree that when you put in, if you say is this continuous in A, then that means what does this do, yeah? And doesn't that equal 0 to 0? Now that doesn't mean no it doesn't do, it just means do more. Do more. So you could do local top or you could do factoring and canceling. So isn't that, then the limit of that approach is 2A, right?
This is with the unit
Oh,
case.
yeah, yeah, yeah.
Now that is to say then, that there's a hole there at A, and the Y value needs to be 2A. So then the question is, all right, if I'm gonna fill the hole, to fill the hole, I need the limit to equal the point. Now the limit is 2A, and the point at x equal A is 4, so it must be the case that A is. So that one you should work on the definition. Okay? All right. Gunners and gunners. The questions, those are all the hardest ones.
Not double using stuff.
Have a good day. I will at some point give you that. Very appreciate it, so no worries there. Have a great day. How are you going to school? Oh, good luck. I don't think it smells anymore myself.
I mean, it does, but it's pretty
Oh my gosh. That's not good.
No.
Pretty good. Congratulations.
Are you saying you and Dave are taking the final?
I'll send a probably Thursday or Friday. Thank you. What day are you taking?
Saturday.
Have a good day. Okay. Hi, B. Animaga.
No. Animaga.
Isn't that what it is?
Just anime.
It's not Animaga?
No.
What's
That's
Animaga?
like drawing.
Animaga is drawing?
Mom.
Animanga?
Sure.
That sounds made up. How you doing?
How can
Oh,
you
I'm
use
still
little notes?
recording.